Hello everyone, welcome to another video. Today we're going to start chapter 10, which is the area and volume of similar figures and solid. Okay, so if you look at the table here, we are going for this very basic one in this video, which is the ratio of the length and the area. So there's some link here which we'll learn later. Okay, so let's start with this one. So as an example, we're looking for the link between the length of a square, which is 1 cm, and the area of a square, of the same square. So if this is 1 cm, you can see that the area will be length times breadth, right? So that will be 1 times 1 equal 1. So if we double the length to become 2, you can see that this is a square with a 2 by 2, right? So if we look at the area, it's actually 2 cm times 2 cm, so that will be 4. So there's some sort of link between this 1 1 and this 2 4. So if we triple the size, you see all these sizes are still similar, right? So if we triple the size, it becomes 3 times 3. So you can see that the length is 3, and then the area is 3 times 3, 9. So at some point, you must realize that if I square the length, I'm going to get the area. So same thing, I square the length, I'm going to get the area, square area. So that's what you are supposed to figure out from there. So in other words, this is a so-called formula where if we take the areas divided by each other, it will be the same ratio as the length divided by each other, just that I got to square it to make it equal. So there's another, I like to use this cheat sheet over here. You can see that I have something like this. So in this case, we have the length of the ratio of the length. If we want to get the area, we simply got to square the number. Okay, so if we square the number for the length, you will get the area. In the same sense, you learn this in the next part of the video. If I have the length, if I cube it, I get the volume. And if I'm given the volume, I can cube root it to get the length. Same thing, if I get the area, I can square root the ratio to get the length. So that's how this whole chapter works. Okay, as you will see more as we go along. Okay, so let's look at another example. This will be triangles. So this is just to show you that even if the shape is not a square, it works too. You can see that this triangle is 1 cm on all sides, and then the area is 1. So one of this triangle is 1. If we double the length to become 2, you can see that it becomes 4 square, so it's 4. And if we triple it, it becomes 1 2 3 4 5 6 7 8 9, so it becomes 9. So this theory actually works regardless of the shape. As long as the shapes are similar, you can see that it's similar, all these shapes are similar in size, in shape, then it will work. Okay, so with this is the two things that we just learned. If I square the length of the ratio, I get the ratio of the area. And if I'm given the area, I can square root the area's ratio to get the length. So let's see how this is being used. Okay, so if you do one example here, you can see that I have two triangles similar in shape. Again, you see they are similar, right? This is the keyword, similar. And then I have one side is 2, I have one side is 8. So these 2 and the 8 are the same side of the triangle. And then I'm asked the area of the small one, given that the big one is 5.4. So how we do this is, the ratio of 2 and 8 is over here, 2 over 8. If I square it, it will give me the area, the ratio of the small area divided by the big area. So that's how this thing came about. And then you can see that this big area is 5.4, right? So that's why it's 5.4. So small over big, small over big. This is the length, this is the area. So when I square the area, it becomes equal. These two becomes equal. And then once I have it equal, I simply multiply the 5.4 over, and I'm solving for the big area, which is this answer. So if we use the other picture, if we use this picture to do it, so there are a few ways to do it. You can see that I start with the ratio big and small, so it's 8 and 2. So over here, 8 and 2. if I square it, 8 square is 64, 2 square is 4, and this will be the areas ratio. Okay, so what I do is I want to find the big triangle where the area is 5.4. So from this 64, I need to change it to 5.4. So what I do is I divide by 64 to get 1, and I times 5.4. That's why the number over here also divide by 64 and then times 5.4, and I'm able to get the exact same answer. Now, which one you prefer is really a matter of preference. I like this method more because this scales on to the next few chapters where the working will be similar. But for this chapter alone, this is actually more efficient, to be honest. Okay, so let's do another example. I'm going to do this method first. Okay, so you can see that again I have a small shape, I have a big shape. I have the length 0.2, I don't have the length, but I have both the areas. So in the same theory, I like to start the equation with the unknown and the top left hand corner. So I start with L. So L over this here, L over this is equal to 5.4 divided by 0.6. So 5.4 divided by 0.6. Now this is length, this is area. So to make them the same, I can either square this or I can square root this. Okay, but I like to leave the unknown just there. I don't do anything to it, so I'm going to square root here, and after that this becomes equal, these two, and that's simply going to times the 0.2 over to get the L1, and that's how I get the answer. Okay, now you can try the next question. You can try this. This is slightly more difficult, but you have the QR code here if you can't do it. Okay, the answers are here. Okay, so give it a try. Don't look at it first. If you cannot get the answer, then you watch the QR code. Okay, now let me do one so-called difficult example. This is considered pretty difficult. So I have this figure, parallel lines, these two. I have the 4 and the 2 and the 6, so all the numbers are here. And then I'm given that this area PUR is 12. So PUR is this one, this big triangle here. This one. This is 12. And I'm supposed to find these two things. So let me find this first. Okay. This is a PTS. So that will be PTS. So I need the small one. So by now, you should be quite familiar. If you have a triangle with two parallel lines like this, so this small triangle is definitely similar to the big triangle. Now you don't have to show it because it's it's understood. It's not chapter 8, 9, right? This is chapter 10. So once we figure out this and the big triangle is similar, I need the sides. So the sides, there is the same side will be the 6 and the 8. So this is the two numbers that we're going to use. So we have 6, 8, and then the area is this one, I don't know, divided by 12, because the whole thing is 12. So that's why it's over here, small over big, small over big. To make these two equal, I need to square the length so that now they are equal. Once they are equal, I'm going to times the 12 over, exactly like the examples before. Okay, so that's how you do it. Now, to do this one, PQU, this is a bit more difficult. So PQU is the big one. This is so-called the side triangle. Okay, so what we're going to do is we need to find the area. We need to do this thing called I call it the common height trick. So let me turn the triangle a little bit. Okay, so you can see that we're going to use two triangles here. We need to find this slanted one, right? And then what we're going to do is we're going to use the big one here also. Okay, so what we're going to do is we are given the area of this triangle, right? So this triangle PUR is 12. So what we're going to do is we're going to do this common height trick, which is for this triangle, the height will be from the tallest point drop perpendicular down, right? So this H is the height. But if you look at this slanted triangle at the side, the height is actually also from here drop down. So that's why this is called the common height trick, because this triangle and this triangle have the exact same height. Okay, and I know that this area is 12, so I'm going to take half base times height. So it's half base, which is 4, times height, which is H, and then is equal to 12. So let's turn back the paper, we're going to do our half base times height equal to 12. If I just shift it around and solve, the height is 6. And this 6 is also the same height for the triangle, this triangle that I want. So this triangle's area now is possible to find because it's still half base times height. So the base will be 2. So eventually my answer will be half times, is it 2? PTS, PUQ. Oh, sorry, this should be 2. So this will be 2, and then the answer is 6 cm square. My bad. Okay, so this how I do the question. So this is what we call the common height trick, which is quite common in a difficult question. They will always do this to you. Okay, so the next part is going to be some practice question. You can see that these two questions are exactly the same as these two questions. So you should give it a try. You can just take a look at the answer first. So the answer is 240 and 4. So let's not look at it, and then you can try yourself. Okay. And then this will be the last question of this part. Again, there's a QR code here, and this question is pretty similar to the previous one with the QR code too. So give it a try before you watch. Okay, and then once you're done, it's good to start homework 1 straight away. There's only 1, 2, 3, 4, 5 questions. It's quite fast one. It's all similar to this sort of question, so it can be done quickly. Okay, so hope you have learned something new. Thank you and bye bye.